Folks, hold your angry comments for now. Like you, I believe. They wield the knives. And we're the meat. When that cursed alarm rings, it's our corporate drone wake-up call. Is our concept of time humanity's greatest illusion? Illusion might sound dramatic, but let's call it a mirage. Humanity's earliest timekeeper, the sundial, emerged in ancient Babylon 6,000 years ago. Time measurement kept evolving. We live by its rules. We measure it, yet feel it slipping away. Our lives orbit around it. But what if time is perception, not reality? At first glance, doubting time's existence sounds absurd. Your alarm keeps screaming. Time to rise and grind. Your boss's Rolls-Royce needs your labor. I digress. Back to the point. Scientists have always claimed that measurable things must exist. Yet now, leading physicists speculate about physics beyond time itself. Are they insane, or are we missing something? What if everything we know about time is an illusion? Just humanity's limited understanding of the cosmos and our own minds? The answers start here. For centuries, time seemed simple and unchanging. Isaac Newton declared time absolute, a universal constant, flowing equally for all. He envisioned the universe as a giant clockwork mechanism. In his view, time was the steady rhythm governing all events. But then came Einstein's revolution in the early 1900s. His theory of relativity shattered Newton's absolute time. Time became relative, intertwined with space, creating spacetime. Einstein showed time stretches, warps, and flows unevenly. For example, a light-speed traveler ages slower than someone stationary. Gravity also alters time's flow. Near massive objects, time crawls compared to space. This discovery reshaped our understanding of reality. Yet Einstein's spacetime might not be the final answer. Contemporary physicists now explore fundamental theories beyond time itself. Modern physicists like Carlo Rovelli propose radical ideas. In his influential book, The Order of Time, Rovelli suggests that the time we experience might not fundamentally exist. He argues time isn't a fundamental feature of reality, but a constructed concept. Our brains' wiring and limited perspective lead us to impose temporal structure on the universe. Our brains invented time's concept. To make sense of the world, we enforce causal relationships through time, creating apparent order from chaos. Think Rovelli's ideas are just a rogue scientist's ramblings. To be clear, he's one of the world's most respected physicists, a pioneer of loop quantum gravity, a leading theory, bridging general relativity and quantum mechanics. Not on the same level as Xiangqian Zhang's unified field theory. Please don't mention him in the comments. Rovelli isn't alone in proposing timeless models. UC's philosophy professor Craig Callender questions time's reality. He states, only by breaking the world into subsystems and studying their connections does time emerge. Where do these timeless concepts originate? They stem from quantum mechanics. Some context. Einstein's relativity describes gravity at cosmic scales, treating spacetime as fundamental. But quantum mechanics reveals a different temporal reality. Time interweaves with space, forming spacetime's flexible fabric, which warps under gravity or velocity. Yet quantum theory rejects time as measurable property. It doesn't evolve like quantum states. In fact, time measurement requires external clocks, implying time's arrow is absent in quantum systems. Some formulations of quantum theory exclude time entirely, yet practically, we impose classical timekeeping when measuring quantum system evolution, creating artificial progression. Time's quantum existence remains debated, with no definitive answer. What's clear? Unlike relativity, quantum mechanics doesn't fundamentally encode time. This creates conflict between our two best theories. Relativity and quantum mechanics clash fundamentally. This problem of time forces us to question time's true nature. Is it real, or an emergent phenomenon? Rovelli maintains. Quantum gravity research reveals, when people try to combine the two theories, for example, in loop quantum gravity, time becomes irrelevant. Some equations describing the universe at the smallest scales, for instance, quantum gravity equations like the Wheeler-DeWitt equation, don't include time at all. According to these equations, the universe can be described purely through events and relationships. No timeline is required. How do events occur without the passage of time? This is hard to imagine. Under the standard Copenhagen interpretation, quantum wave collapse drives interactions. A particle's wave function collapses when interacting with its environment, creating a chain of collapses in succession. This creates the perception of time. It's like dominoes. Each falling domino represents a wave collapse, arranged in sequence. They simulate forward-moving time. Carlo Rovelli suggests, reality isn't objects moving through space-time, but a network of interactions. He states the world is fundamentally relational rather than material. An analogy: like watching a film, you're actually seeing static frames. Standard movies run at 24 frames per second, but your brain blends them seamlessly. This creates the illusion of continuous motion. Similarly, our universe isn't made of time, but particle interactions. This applies to everything in reality. Time is just how we perceive these interactions. No universal clock ticks in the background. New research in FSC/LU journal supports this. The key is quantum entanglement. Here's how they reached this conclusion. The paper shows entanglement could be time's origin. Researchers propose time emerges from quantum scale entanglement. Their experiment showed an object's time perception emerges via entanglement, using another quantum system as clock. But unentangled systems experience no time. The universe appears frozen. By entangling two quantum states, a vibrating oscillator and microscopic magnets acting as clocks, they perfectly fit the Schrödinger equation. This equation predicts quantum behavior. Their famous equation version replaces time with tiny magnets acting as clocks. This shows entanglement with clocks represents time in quantum realms. Notably, they not only use quantum entanglement to define time, but also found their equations reduced to classical physics equations. This suggests even for macroscopic objects, time's flow emerges from entanglement. Thus, even our classical experience of time arises from quantum entanglement. But of course, we experience it as good old Father Time. If time isn't fundamental, why does it feel so real to us? Why do we perceive distinct past, present and future? Rovelli argues, the answer lies in our ignorance. Our perceived flow of time and forward direction from past to future result from incomplete quantum information. Limited knowledge forces simplified perception of reality. Time's apparent unidirectional flow, tick by tick, masks simultaneous quantum events. He says, this ticking clock perception relates to thermodynamics' directional concept, entropy. Entropy measures disorder. The second law of thermodynamics states, in closed systems, entropy tends to increase over time. See my episode 129 explaining cosmic thermodynamic codes. Rovelli posits, our experience of time's forward direction directly links to entropy's growth beyond clock mechanisms. Our brains interpret this march toward disorder as time flow. The universe began low entropy, highly ordered, and has moved toward greater disorder since. Entropy's rise creates illusion of progressing time. Not actual temporal flow, but rather cosmic disordering. However, not all physicists accept Rovelli's radical view. Some, like Lee Smolin, argue time is fundamental, not illusionary. In Time Reborn, Smolin challenges time as perception theories. He argues embracing time's fundamental nature could revolutionize physics laws' understanding. Smolin proposes, cosmic laws themselves may evolve over time, and only by accepting time's reality can we fully grasp cosmic mysteries. What implications does this hold? Is time an illusion, a construct of limited human cognition, or is it an intrinsic part of the cosmos, as real as the matter and energy forming stars and galaxies? To answer this question, we must fundamentally rethink what physics is and isn't. This may explain why most physicists endorse time's existence, confidently assuring us that time is indeed real, while physics is philosophically guided. Its core mission is explaining reality through testable mathematical models. Some physics branches diverge from this path, like multiverse theories, which may appear well-defined, but remain philosophical, as they can't be tested or falsified. Untestable physical theories lose practical value. Time's unreality appears as another unfalsifiable claim. Humans qualitatively experience what we call time. Theoretically, we quantify it in equations and measure it with clocks. Given this, how can we claim time isn't real? Relativity makes time fundamental to reality. Yet remember, this same theory abolished gravity as Newton knew it. General relativity redefined gravity as an emergent feature of spacetime curvature, not a fundamental force. Could time also prove non-fundamental like gravity? Possibly. Future theories might restore gravity as fundamental and disprove relativity. Even then, some emergent time concept must match observations. We seek reality's true nature, beyond what time measurements suggest. We want truth, but physics deals in predictive models, not truth. Its role: create predictive cosmic frameworks. At quantum scales, time likely isn't fundamental. No single paper can prove this, but if repeated tests and papers confirm time's unreality, with no contradicting evidence, we may accept time's illusory nature. Time could be humanity's greatest illusion. Now a practical question. Do you eat when hungry? Or stick to fixed meal times? Share your thoughts below, citizen scientists.